Welcome to this in-depth Cycode review, focused on what matters most to AppSec and platform teams: real risk reduction, consolidation, and measurable impact on mean time to remediate. If you are considering an application security posture management platform, or ASPM, you are probably drowning in alerts from standalone tools and looking for a coherent way to prioritize and fix what truly matters. Cycode positions itself as an AI-native ASPM that centralizes security from code to cloud. Let's break down how it works, where it shines, where to compare alternatives, and how to evaluate it for your environment. First, what is ASPM and why does it matter now? ASPM is a category created to unify and orchestrate application security across the software development lifecycle. Instead of separate silos for SAST, SCA, secrets detection, IAC scanning, and CI or CD pipeline hardening, ASPM correlates those findings and adds context for runtime environments. The outcome should be fewer duplicate alerts, higher confidence in prioritization, and automated workflows that get fixes into pull requests or tickets quickly. Cycode's core value proposition is consolidation and context. The platform connects to your source code managers like GitHub, GitLab, Bitbucket, and Azure DevOps, integrates with CI systems such as GitHub Actions, GitLab CI, Jenkins, and Circle CI, and pulls in cloud and container context from environments like AWS, Azure, GCP, and Kubernetes. With these integrations, Cycode builds a code-to-cloud map that links a vulnerable repository, the pipeline that built the artifact, the container image that shipped, and the service or cluster where it runs. This end-to-end view is the backbone for prioritizing threats by actual impact, not just severity labels. A frequent question is whether Cycode actually uses AI and what that looks like in practice. Cycode emphasizes AI for correlation, deduplication, and risk ranking. When multiple scanners flag overlapping issues, the platform works to merge those signals, reducing noise and showing a single enriched finding. AI-driven context and graph analysis help identify exploitability and potential blast radius, so teams can tackle items that intersect sensitive services, internet exposure, or critical data paths first. In addition, AI is used to enhance remediation guidance in plain language, helping developers fix issues faster without digging through multiple reports. Let's cover key capabilities. On the code side, Cycode supports SAST for first-party code vulnerabilities, SCA to identify risky open-source dependencies and licenses, and secrets detection across repositories and pipelines. For infrastructure as code, it scans Terraform, CloudFormation, Kubernetes manifests, and similar files to catch misconfigurations before they reach production. In CI and CD, it checks pipeline posture, such as hardening for GitHub Actions, GitLab CI, and Jenkins, and can flag risky patterns like overly permissive tokens or unpinned actions. Supply chain features include SBOM generation and governance, policy checks for branch protection and signed commits, and controls to reduce the risk of tampering from code to container to runtime. While some teams rely on separate tools for DAST or container scanning, Cycode's ASPM approach focuses on unifying signals and adding the surrounding business and runtime context that determines priority. Risk prioritization is where ASPM earns its keep. Cycode's context engine correlates vulnerabilities with the services where they actually run, external exposure, data sensitivity, and reachable paths. This means a medium-severity library flaw on an internet-facing microservice tied to payment data can be prioritized above a critical issue in a dormant internal app. That kind of ordering is what helps security and engineering leaders cut backlog and drive down MTTR. Workflow and remediation are crucial for adoption. Cycode integrates with pull requests, issues, and ticketing platforms so teams can raise fixes directly in developer workflows, not in yet another dashboard. You can define policies to block risky merges, enforce SLAs, and automatically create tasks with pre-filled details and references to the code or IAC line that needs attention. The aim is to shift left without slowing velocity by being precise about what to fix and why. Customers often ask about measurable results. The most common benefits attributed to ASPM include fewer duplicate alerts, faster triage, and better collaboration between security and engineering. One customer said, "Cycode is one of the best platforms in the market that allows us to centralize everything in one place, replacing multiple tools." In addition, industry analysts place Cycode among the top ASPM solutions and top software supply chain security tools, underscoring its position in the market. Your results will depend on the thoroughness of integrations, policy tuning, and developer adoption. So plan time for a proof of value that exercises your real repositories, pipelines, and cloud environments. How does Cycode compare to alternatives? In ASPM, notable peers include AppIero, Armor Code, and Legit Security. Developer-first scanning may lead you to consider SNCC or GitHub Advanced Security, especially if you prefer deep integration inside developer IDEs and pull requests. For cloud-heavy posture and workload context, teams often evaluate Wiz or Prisma Cloud alongside ASPM to harmonize application and cloud risk. The differentiator to look for in Cycode is end-to-end consolidation with meaningful correlation. Does it actually reduce noise across your existing scanners, and does it produce a clear, prioritized queue that your developers will act on? On pricing and packaging, ASPM vendors typically use a sales-assisted model with scope-driven quotes. Common drivers include developer or repository counts, number of pipelines and integrations, and the breadth of features you enable. The practical step is to request a proof of value. Define success metrics around alert reduction, time to fix, and policy efficacy, and then use those results to benchmark total cost of ownership versus your current toolchain. Security governance and compliance are also part of the evaluation. Cycode supports policy controls in Git and CI to enforce guardrails like branch protection, code owner reviews, and pipeline hardening. SBOM generation and dependency governance help with frameworks like SOC2 and ISO 27001, while supply chain integrity checks can support secure build initiatives. Look for the ability to document remediation SLAs, track exceptions, and export evidence for audit. Who should consider Cycode? Organizations with multiple AppSec tools looking to consolidate and introduce consistent risk scoring across repositories, pipelines, and runtime will likely see the most value. Teams building microservices on Kubernetes, operating across AWS or Azure, and running multi-repo GitHub or GitLab setups can benefit from the code-to-cloud graph and AI-assisted prioritization. Platform engineering and DevSecOps teams that own developer guardrails will appreciate the policy workflows and integrations with PRs and tickets. How to evaluate next steps. Start by connecting a representative set of repos and pipelines. Then bring in at least one production-like runtime environment to activate code-to-cloud context. Establish a baseline for duplicate alerts and triage time, then measure how correlation and AI-driven prioritization change those metrics. Validate remediation flows in PRs or tickets. Ensure policies align with your engineering culture, and confirm that the platform can scale across business units. In summary, Cycode offers an AI-native ASPM approach that centralizes critical AppSec functions and maps them to real operational impact. Its strength lies in correlation, deduplication, and developer-aligned workflows that move fixes forward without overwhelming teams. If your goal is to reduce noise, shrink MTTR, and connect application findings to actual runtime risk, Cycode is a serious contender to include on your shortlist.